Okay, let's get going. Okay, welcome everyone. This is our first OAUTH session, and Hannes and I will drive this discussion, and Hannes is remote here. Hey, Hannes. Okay. Thanks to Justin and Pam for taking notes. Appreciate that. This is our new NoteWell, so please make sure you get familiar with that NoteWell. It governs everything that we do at the IETF, including the expected behavior, professional, respectful behavior to each other. So yeah, please, and IPR too, and harassment, all of this stuff, it's important. So yeah, pay attention to this, okay? Tips, please make sure to log into Data Tracker. It will help us understand how many people attend, so to plan for our next sessions, and it will help you kind of join that queue if you want to speak up. For remote participant, please make sure you are your audio and video are off unless you want to speak up. And please state your name at the mic. A quick update from that work group. So we have a token status list is with the ISG. Last call, it should end soon. It's good there. A browser-based app, it's with the RFC editor queue. There's a misref with that specific document. I think it's with the ISG right now. Is Deb here? Give us an update, maybe.
So the answer is it is complicated. So the HTTP cookie draft he's still working on comments. Mike Bishop's gonna tell him he's agreed to publish a new draft, and then Mike Bishop will let it go, which will take the browser-based draft out of misref right behind it, right? So it's there with it. I think that draft is holding up a bunch of other work as well, not just the OAuth work.
Okay.
So
okay. Thanks.
That's today's update.
Yep. SDJOT is with the RFC editor queue. Do you know what's the latest on this one? Sorry.
Yeah, well, I have not asked. So I had just asked for 2 drafts to be expedited. And so I was unwilling to be that AD. And so now that those 2 drafts have been published, maybe I can now be that AD, or at least ask for when they think it'll come up to be worked on. Should be any day.
Yeah.
Honestly, it's been there for a minute. Yes, because that's what was on the RFC when they did that meeting that the RFC editor does. They said it was like next in the queue, right? So, and it was yeah, it should be soon.
Yeah.
But I think the editors, that particular editor's here, so I can ask her.
Okay. Yeah, so that nothing is blocking there. So it's just a matter of working.
It's just a dense, long, complicated draft, and you know.
Yeah. Okay. Thanks, Deb. For the cross-device flows, I think Hannes is ready to kind of move this along. The write-up is ready, but we are waiting for one IPR disclosure. I don't see Peter. Is Peter here? Oh, sorry. What's the latest?
Not disclosure. For the confirmation that all these IPRs have been disclosed, but there may not be an IPR, so there may not be.
Right.
disclosure.
Yep. Go ahead.
Yeah, so I think from our exchange of notes earlier today, Hannes, the outstanding pieces, we are waiting on Daniel to confirm a few
correct.
things. And
It just came through to the mailing list a couple minutes ago.
excellent.
Okay.
Sorted out.
Timely, perfect.
So the write-up, we'll have to write up tomorrow, Hannes, is that right?
No, I will edit it right now and click the button.
Yeah, it's almost, it's ready, right? So, okay, perfect. Thank you.
Just for completeness, we also have the ID chaining, which is in working group last call, or I believe waiting for the shepherds write-up as well.
Yeah, but like we didn't do anything with that yet. We said like we will pick it up after Montreal, right? So
Okay, thank you.
yeah, thank you. Okay. So here is our agenda for Monday. As you can see, it's a packed agenda, so we'll get going very quickly here. We still have Friday, the last session again, so hopefully we'll see you there on Friday too. Okay, that's it on my side, so let's get going. Brian. And I'm gonna hand you the clicker here. Yes, yeah. Go for it.
Okay. SD-JOT BC, which is different than SD-JOT. I get the pleasure of giving you all a status update as I'm here in Montreal and my co-authors are not. And so, as is traditional, I start with a nice picture of Montreal to get us started. So, yeah, it works. Real quick overview, try to set a little bit of context before we get into the ugly changes. And I know it's not enough context for people that are just showing up for a session, and it's probably too much context for people that are familiar with it, but let's try. So SD.BC describes data formats as well as basic validation and processing rules to express verifiable credentials, which you might also know as digital credentials or verifiable digital credentials, or pick your name, but the general idea of a digital type credential using a JSON payload, both with and without selected disclosure, building on top of the SD-JOT format. The SD-JOT is the one that we were just talking about that's proceeding hopefully to publication like in the next days or weeks. It uses SD-JOT and the well-established JWT content rules, an extensibility model as the basis for representing these VCs or DCs or VCDs. We define these issuer signature mechanisms as a construct and sort of general construct for signature validation routines on these documents or these VCs, and provide two common mechanisms for general interoperability and reuse. And one is a web-based metadata resolution via a well-known document and online JSON web keys. And the other is an inline X509 mode with the existing X5C header in the JWS document. We also have a fairly extensive section that's describing type metadata, which is different than the issuer, but some metadata content describing basically the document itself, allowing for some understanding of rules about what's in the document, how to display that to an end user, not actually defining the UI or the display, but providing informational type fields to give implementations, particularly on like a device, a user's device, a smartphone, about how an instance of a credential might be rendered in a user-friendly way, as well as some rules about which claims, which attributes are required, what might be mandatory, which ones have to be selectively disclosable, which one have to be there normally, a number of things like that that really describe the content type of the particular document itself. And I'm sorry I said content type, not like a media type or anything, but just the structure and format of that particular type of JSON document. So we've been doing actually quite a bit of work since Madrid, the last two updates, and my eyes aren't good enough. I think it's 11 and 12. It's embarrassing. A lot of work was put in since then, trying to get the document ready and moving forward, and almost as much work has gone into the document as went into capturing this picture here. You can see me hiding in the bush on the rooftop of a building there, trying to get that. Oh wow, my eyes. I know there's no dumpster fires, there's no burning buildings. Madrid was a lot friendlier in that sense. But so in draft 11, this is taken right from the document history, but hopefully gives a reasonable idea of what's been going on. We clarified the extend support for claim metadata. So in the type metadata, you can describe the claims that you expect to be in a particular credential. And there's also constructs for types to extend other types and sort of use a prior one as a base definition, which is really useful. But we added a little bit of clarity around what it means to extend and what kind of claims can override others or just add to the existing sort of base definition. We talked a little bit about some privacy concerns, mostly around the use of the X5U header parameter, but also about JWKs and other similar remote retrieval mechanisms for obtaining keys. So throughout JOTS, all the way back to the beginning, there's different ways to describe the key that was used to sign and thus expected to be verified, both at the JOT level as well as the confirmation key. And some of those involve putting a URL into the document itself, either in the header or the body. And that has a lot of implications around the privacy, because you can embed callback URLs and things like that in that content, as well as difficulty on the verifier about forcing sort of remote retrieval of various URLs, all of which is really problematic. So we just added some text basically very strongly suggesting not to do that, not to issue them that way, and not to resolve any of that content as a validator, either in the holder position or as a verifier. Let's see, we added a section on credential type extensions and issuer authorization, really just a note saying that just because you extend some other type, it doesn't mean you're actually authorized to issue credentials of this style. Really the kind of use cases we're trying to just point people to there are like a general government, maybe broad category of user documentation that then can be extended by others for more specific purposes. But just because there's an extension, it doesn't sort of infer some level of authority that the base type might otherwise extend. And we just described that a little bit. Fixed a small inconsistency, added the VCT pound integrity to the list of claims that cannot be selectively disclosed. That's a bit of an integrity check back to a document that describes the type metadata. And there's an option to include like an integrity field over the content of that in the document itself. We're just saying that if that's included, it can't actually be made selectively disclosable. It has to always be there in the clear. We removed the entire concept of a glue type metadata document, which was a way to embed type metadata inside of the unprotected header of the JSON serialized variant of the SD-JOT itself. It was a sort of complicated way of doing things for a data format that's not widely supported, that added a lot of questions about the security and safety of doing it that way at all. And as we look towards trying to get something out here and push it out that can actually be used and implemented and deployed in the real world, we made a real effort to remove things that were not strictly necessary, that brought with them a lot of complications. And the so-called glue type metadata document was one of those. So it's simply been removed. Did some editorial updates, mentioned very clearly that when the status claim is present, and it's using a status list, which is sort of the main defined status list variant mechanism, the associated status list token, the status list that you go and retrieve, has to be in JOT format. It can't be the CBOR variant, just for sanity and interoperability. changed the definition of the VCT data type to just be a string rather than the somewhat beleaguered string or URI definition of a data type from base JOT, which is not widely understood and I don't think deployed very well. It's not a very helpful data type, so we just switched it out to be a string. We had also a 12 published. We changed in the type metadata, excuse me, lang to locale. While many think that lang is a more accurate way to describe this, the locale has been used in very similar contexts throughout sort of this sphere of specification. So we tried to align those for better, at least sort of semantic interoperability, meaning like people understand it and see it when they see it, whether it's right or wrong. That's where we've gone. Removed JSON schema and its validation requirements and its overriding and so forth from type metadata. That was another one that was really geared at too complicated for what it provides. Removing its support from type metadata doesn't preclude any kind of usage, but it does take away a lot of very serious problematic open questions that needed to be resolved. And in the spirit of trying to progress things and get something out that's actually useful and implementable, it's been removed from the standard type metadata. Tried to clarify some stuff about ignore if not understood. The base rules about JOTs are you have to ignore content that you don't understand. And you are allowed to, in specific profiles or implementations, change those rules. But we wanted to just sort of default to allowing for that and allow various types or various profiles to say whatever they want, not try to restate or override the rules here. It's really more just sort of removing duplicate content that might be misunderstood. Who knows what this is? Clarify that an SD.jot VC doesn't contain a KB jot, but rather might have an associated one, which makes it an SD.jot plus KB. And Brian, that's me, is still unsure about the term or the way we use these words, but it's kind of where we've landed. And really it is some semantic change of words and styling in the base document that hadn't propagated fully through. So we tried to align the terminology, and that was a lot of words to say, fixed up some terminology. Remove the requirement to ignore unknown claims. Weirdly, I just talked about this in a previous bullet, so I don't actually know what the previous one meant to be, because that's what I was talking about. Oh, just, sorry. The previous one was about explicitly saying that you have to ignore stuff you don't understand in type metadata. This is about just not saying anything about claims because that's already sort of the baseline requirement. Fix the CNF claim and JWK references and move them to being normative, just some moving things around within the document. List VCT is one of the required values in type metadata. It was sort of implied to be, it wasn't mentioned. And ensure that the use of the document integrity associated claim is clear about how that works. That again, too, is just sort of some housekeeping stuff. And remove the entire discussion of the status claim and status list provider from the introduction. It was all optional anyway, but it felt like it detracted from the overall sort of message of the document, as this stuff is all covered in the token status list content document itself. And so sort of repeating it here in the introduction felt somewhat problematic. And there were some comments received on the document about changing the way that worked, which kind of back to my theme of it's harder to fix things that aren't even necessary in the document themselves than to just remove them entirely and let the authoritative document on that piece take care of that. Wow. So in part 2 of 12, and I did use the French here for you, Jeff. I hope you can check it for me. Adds a background image property to the simple rendering method, which was a way to try to simplify, not simplify, add additional support to the different ways you could display a VC to the end user, including a background image that's commonly used in the type metadata. Made some recommendations about how you use always or never in terms of how you make things in the type. I'm running over on it.
No, you're good,
Oh.
good with that. But somebody in the queue, do you want
Is
to
this
take
you?
questions or?
It's probably, if it just came up, it's probably related to something I just
Right.
said, so let's
Yeah,
do
yeah,
it now.
maybe.
Yeah.
Okay. Dimitri? Dimitri, can you hear us? Maybe not. Okay, keep going.
Okay, keep going if you figure out. Dimitri,
Yeah.
come on back to us. Anyone? Bueller?
Yeah, no.
Bueller?
Hannes, you can hear us, right?
Yes, works
Yes.
fine.
Yeah. Yeah, keep going.
Okay, I'll keep going for now. If I can remember where I was, some stuff about just explaining a little bit better about recommending when to use certain combinations of how you describe things in the type metadata. Some guidance was provided around how you might go about versioning credentials using the VCT value. It's nothing normative, but it was tried to sort of state some of the things you might want to take in consideration when you're rolling out actual, I don't know what the word is, deployments of this, or actually usage of these with particular credential types, and how you might migrate them and use them over time. Some security considerations about why and how you would have any trust in type metadata itself and what that would mean. Described a little bit about using data URIs for non-JSON supported types, really just giving some guidance on using data URI with the associated encoding to do things like how to convey image data or other things that there's not a native JSON type for. We require the X5C header to be in the protected header. It's sort of implied, but we're a little clearer about it now. Clarified that presentations of an SD.VC do not always require a key binding associated with them. Oftentimes they do, but they don't always. Expanded some of the examples so they're a little bit more clear. Tried to be more consistent with the style for how we list out required claims and editorial stuff. Updated the PID, the personal identifying somebody from Europe, helped me, PID example to make it clear that it's not strictly normative. It's an example of how this kind of construct might be realized using JSON in this format, but tried to make it really, really clear that it was a hypothetical example and not normative in any way for that layer of work. And gave some clarification on processing of display metadata. That doesn't say anything, and I can't remember what we actually did in that, but I'm sure it was important at the time. All that is to say that, my clicker, we got ourselves to 0 issues in the issue tracker, and before I was able to take a screenshot of it, we got one that came in, so we had a brief celebration of the moment. But thankfully, this issue is relatively straightforward, and it was just sort of a mismatch between two things. And the reporter has already filed a very thoughtful and nice pull request to address it. We just haven't put it in yet. And so we're going to be back to 0 issues recently. And I forgot this was in here. Meanwhile, while we're talking about all this, going through this work, trying to produce these documents, there are external organizations, one of which is the European Union, that is interested in producing and publishing work that relies on this content. And so relies on this document. And it would be really, really useful if we were able to provide them with stable, finalized references to this stuff. It's always a really tricky line to walk between, you know, trying to accommodate external needs and pushing things too quickly, or not accommodating the needs of the internal organization ourselves. But there is a reality out here that there's external factors on which depend on this work, and it would be great if we could get something out reasonably soon, given all the other constructs that can satisfy the needs of some of these organizations. This actually just being one, an important one, but one of them. And that's when my clicker really doesn't work. One more. So I don't want to be too cute with it. I don't want to push things too quickly, but I really do think this document, given its content, given the larger forces at play, is ready for consideration for working group last call. And that is Trash Panda from Montreal, that is. It is not on fire. It is
Okay.
not.
We have very
So
short.
that's a local focus. All right, I'm out of
Okay.
time. Oh, I'm over
Yes.
time.
No, you have a few minutes, maybe. Okay, any comments, questions, suggestions?
Not everybody at once.
Yeah.
Well, the question would be like, who has read this most recent version? Because, like as you said, like you have made numerous changes.
Yeah. Yeah, that's a good
Those feel like a little bit like on one hand we have the sense of urgency, but then you axe out a lot of content, probably rightfully so because it was too complicated. But then why was there complicated stuff there in the first place? So it's often because back then it wasn't presumed to be or wasn't seen as complicated.
So maybe, Hannes, maybe we can try to get a raise of hands for people that read the latest version. If that might give us some insight. So,
yeah,
who read the latest version of the draft? Raise your hand, please. Oh my gosh. Okay, not too many people. So, can we get volunteers to review the latest draft?
I assume you've got 4 people in the queue who have raised their hands to indicate that they read it.
Okay, so I got Nat and Dan. Anybody else? One more, please. Tim. Okay,
We've
perfect.
got one in the.
Oh, okay. Who? Okay, so we have a number of volunteers to review it. So let's do that. Let's get that done on the mailing list and see what we get. And then after that, we make a decision about what group last call.
That's fair.
Okay.
It is a fair question, Hannes. And there were a lot of changes, but they're definitely scoped at improvements and simplification. So I understand sort of the discrepancy you're pushing out there, but I don't think it's as large as it seems. We're really trying to push it forward, simplify it, improve it, and get it forward. So this is a good outcome.
Okay.
Get some people to read it and see what we can do.
Awesome. Thank you, Ann. Okay.
Yeah, it would be terrible if you say otherwise, right?
True.
But good. You at least like the work. Great.
Okay.
Oh, it's Aaron.
Is it your Aaron? Yeah. So, which one? Is it delegate? Which one is it?
I think the first one is the
Agenda.
assertion.
Oh, okay, got it.
I'm a lot shorter than Brian. There we go. Fair.
This one?
Nope,
Let me hand you the clicker.
that's the wrong one.
Not this one?
Nope.
Nope. Oh, that's yours.
It's identity assertion.
Okay, hold on. Oh, this one probably.
There we go.
Okay. Let me hand you the clicker now. Try it.
Great, that's me.
Yeah. Okay.
Welcome. Hi, Aaron Parecki. This is a view out of my hotel window here from yesterday. Okay, I'm going to do a quick recap of what this draft is, and then I'll get into some of the open questions that I wanted to discuss, but just for some context setting. The Identity Assertion Authorization Grant is a profile of the identity and authorization chaining across domains draft. All of these are a lot of words. So what does this actually mean? The problem that we are tackling with this draft is applying the identity chaining across domains to the enterprise context. What this means is in a typical enterprise deployment, you have an IDP that is used to sign into many different applications in the enterprise through single sign-on protocols like OpenID Connect or SAML. That's all great and not really relevant to OAuth other than they might be using OpenID Connect, which is built on OAuth. But what is relevant is what happens when these apps want to talk to each other. For example, a wiki page like this wants to go and embed content from other applications that are used in the enterprise to have something that looks prettier than just a long URL in the wiki page. Or any number of other scenarios you can imagine, some of which are now involving AI, which is fun. In order for this to work today, the way what ends up happening is the application, like a wiki, will send the user through an OAuth flow to the application it's trying to get access to, and the user will see a prompt like this of this application wants to access whatever data in your account, your contacts, your email, whatever, your documents. And if you look at what's happening here, the flow is one app does an OAuth flow to another application. They might sign into the enterprise ID through the enterprise IDP, but the IDP only sees that a user is signing into the chat app or the video conferencing app, and the IDP does not actually know that that one application is going to be issuing an access token to another application. So essentially, it's this massive blind spot of the enterprise IDP that is intended to control access to data in the application, being completely unaware of data sharing that is going on between applications in the enterprise. So this is the problem space, and essentially what we want to do is make it so that the IDP can be aware of this data sharing and these OAuth grants that are happening between applications. So that is the Identity Assertion Authorization Grant. The idea is to extend the concepts of single sign-on to include API access between applications. This does two things, which are often not possible to do in the same time with the same protocol in our space, which is, one, we improve the user experience, and two, we also get better security. I think that's pretty cool. So the user experience side is, instead of the user having to go and say, yes, I want this app to get access to this other app 20 times for all the apps they're trying to connect to their new AI chatbot, they just log into the first app and it can just get all the access it needs through the IDP, while moving the control of whether this is even allowed into the enterprise IDP, which is where everything else is maintained anyway. So the way this works is using the identity chaining across domains framework, which says, take something, some sort of token, do a token exchange to get a JOT, use that JOT as a JOT authorization grant to get an access token. So I'll go through this in a little bit more detail with some more concrete examples. So first, you have the application that's trying to get access to a resource. It will do single sign-on through however it wants. That's not part of this protocol. Let's say it's OpenID Connect. It'll get back an ID token from the IDP. Then it will take the ID token back to the IDP and say, hey, I'm trying to get access to this other application. And it gets back a new JOT token that we are calling an ID JAG, Identity Assertion JOT Authorization Grant, ID JAG for short. That is the JOT that moves across domains to the other domain, which is, so step 5 here, present the JOT authorization grant to the authorization server that is protecting the resources trying to be accessed. It can validate that token because, again, both of these applications have a single sign-on relationship to the same IDP. And it can validate that JOT, check the signature, check all the claims, and then issue its own access token. Okay, so that is the flow. This is one of the main things this draft in particular does is actually defines the claims in this JOT. In the parent draft, the identity chaining draft, the actual claims are left as an exercise to the reader because you can do many different things with it for many different reasons. And now we're saying this is exactly what to do because both are under an enterprise IDP. So what has changed since the last version? The last version was the same as the one previously presented. Version 0.0 was the adopted draft. This was adopted a month or so ago. And based on a combination of the feedback we got during the call for adoption, as well as some feedback from people who are currently implementing this, made a handful of changes. Most of the feedback during the call for adoption was asking for clarity around things, either it wasn't clear because this was in the wrong order, or this term was not used, was used in a weird way or whatever. So one of the, probably the most like structural difference in the draft is this, because most of what this draft is doing is defining the IDJAG concept, that's now like pulled out into a parent top level item in the document hierarchy. We also did a big pass on renaming what we called things to more standard OAuth names. So you'll find now things called client and resource authorization server and IDP authorization server. So hopefully that's a little bit more consistent with the rest of the OAuth terminology. There's one of the goals is that this IDJAG does represent, at least in part, the what happened during single sign-on. So we actually added more explicit references to additional claims you might find in an ID token that can be pulled into that. Those are examples, they're not required, but the idea is that you could put anything into this. You can extend this IDJAG token with additional claims about things like the authentication methods, or what's the one for the time the user logged in, auth time or something. There's a new section on recommendations for dealing with refresh tokens, although I want to talk about some of those here. And that's enough of that, because I want to get to the things that I want to talk about next. Changes we want to do for the next version. There are, I'm not going to go, we don't need to discuss this first one, it's editorial, but it's essentially there's room to improve the discussion around how user IDs and client IDs are mapped between the three parties, because there are three parties involved, all who have their own idea of how to identify users or each other. So it's just a little tricky to get that to work. It's all possible. There's no protocol changes needed to make it all work, but more discussion of that is clearly needed based on feedback we've been getting from people who are building this. The three that I do want to talk about in the next 11 and a half minutes are refresh tokens as another way to get an IDJAG, how this works with proof of possession binding, and the third one, which I'm not sure we have time to get into because it's very complicated, is the whole concept of multi-tenancy in these applications. And related, but I think it's actually out of scope, and maybe we can just do a quick gut check here. One of the first questions people ask is, as a client, how do I know what applications I can even do this with in the enterprise? To me, that feels like it is a question to ask the IDP authorization server, but it also feels like it's not something that belongs in this protocol. It feels like it's kind of a separate thing. I don't know, I see a couple of nods. Up for discussion. I'm up for discussing that. Grab me after the session sometime, we can chat more about that. So, okay, the refresh token one. This is the first one I want to dive into for reals. So given the flow that you just saw of user logs in, gets an ID token, the app takes the ID token to get an IDJAG, uses the IDJAG to get an access token. What happens when it's been a while since the user has logged in? So the current draft has this sequence of recommendations. If the access token's expired, so the question starts with, you're going and accessing the resource, and then at some point that access token's going to expire for some reason. It could be that the token only lasted an hour, it could be that it lasted a day, whatever. If the access token's expired, use the IDJAG to get a new one. If it's not expired. If it has expired, we need a new IDJAG. So use the ID token to get a new one, if the ID token is not expired. If it is expired, we can use the refresh token that we got through single sign-on to get a new ID token, and then use that ID token as, to start the flow again. Essentially what that means is that in that case, which is probably the most common case because it's very likely that the ID tokens and the IDJAGs are short-lived, at least relative to everything else. In that case, it actually means that there is going to be a redundant request of use a refresh token to get an ID token, and then go back again to use the ID token to get an IDJAG, and then you continue on. So the proposal here is replace step 3 with use the refresh token itself directly to get a new IDJAG, which essentially means we're adding a new input token type to the token exchange request that was in that first step. Brian says thumbs up. He likes it. I think I don't see. So the conceptually, the refresh token is meant to represent the ID token over a longer period of time. And again, we don't need to define it, but the assumption would be that it was requested with the offline access scope or whatever. So they seem to be equivalent to me, and that's why it feels okay.
Okay, let's get the queue going. Jeff.
Yeah, very quick comment. Jeff Lombardo. When you refresh, you don't necessarily get a new ID token. If the ID token is the equivalent of the ID JAG, then you might not necessarily expect an ID JAG to be returned from the refresh token, right?
Sorry, do you mean when you use a refresh token today in current OpenID Connect?
Yeah, I think it's not mandatory to have like an ID token being returned, because using a refresh token flow is not necessarily considered a user authentication at the end of the day. Therefore, a new proof of authentication might not be returned.
That's true, yeah.
Okay, so if what you seem to point out is that to consider ID token and ID JAG to be equivalent?
No. So treat the ID token and the refresh token as both things that represent the user's authentication at the IDP. And we need to get a new ID JAG that represents their authorization for the other resource on the other domain. Do I have this in a diagram on the next slide? No, I don't. Okay, let me go back to the diagram because it's easier to point at things when they're in this picture. Mm-hmm. So in step 2, today, it is possible that that also includes a refresh token in the response, right? Mm-hmm. And then today, that means if the access token is expired, you would take that refresh token and go back and get a new ID token, which is implemented in many OpenID Connect systems, although I agree it's not a requirement that an ID token is returned. So the idea would be that we replace step 3 here with the refresh token to get a new authorization.
I got the intent. I was just saying there is into your bullet points, I think there is a 4th bullet point, which is like if the ID token is not returned onto refresh flow. That's the only point.
I see. Okay.
Justin.
Hi, Justin Richer. Jeff said most of what I was going to say, that this is not a universal pattern. I think it might be interesting to see if, like with offline access, we can define some way to signal that I want this refresh token to have this particular behavior. And it's getting into defining scopes, but we're already kind of in semantic territory here, so I don't think it's that crazy. It's a little crazy, though. But it is at least as crazy as expecting everybody to return ID tokens in the first place from a refresh token, because I know quite a few systems that very explicitly do not do that because of the separation of what an access token means versus what an ID token means.
So actually, that actually sounds to me like a very strong argument for adding this refresh token concept as the input to return a new ID JAG, because
Yeah, exactly.
Yeah, okay.
So because the refresh token is the representation of the longer term grant from the client's perspective, ergo it is a reasonable handle to get to the next stage of what the thing is that you want. The missing bit, because we didn't think of this in OAuth2, is refresh tokens are defined as how you get an access token, and maybe a bunch of other stuff kind of comes with that sometimes. Very hand wavy. If we could define a semantic way to signal that, to carry that, I think that would be better, but I don't know exactly how we would do that. I think that's something this draft might want to tackle, though. Yeah. Okay, Brian's nodding, so I must have said something smart.
I largely agree with all that. There's something a little fishy, but generally good, and I think can be reconciled. Just noting that the refresh token presentation in what would be step 3 would be as a token exchange request. So the semantics are a little bit different than a normal refresh, give me a token. It would be a token exchange with all the syntax and pomp and circumstances of this is a refresh token. I'm requesting an ID JAG back. that clarification, Ahmed, there might still be something to what you're asking for, but it is a little different. Thank you.
Thank you for that clarification. That actually, I think that gives us a much cleaner place to actually hang all of that extra semantics on top of. So yeah, let's do it.
Cool. Thanks.
Hello. I do worry a bit that we're going to have many different ways to get to where we want, and that adds a lot of complexity. So I do wonder if we shouldn't just make refresh token the #1 way to go to. It will make things much easier for implementers, much easier to use, and also more clear in a way that you cannot get from an ID token to ID check to an access token. You have to use the refresh token to do so, and that is what it was meant to do, right?
So your proposal would be, even in the base case, to use the refresh token
yes,
first,
because
not
if
the
you
ID token.
need it anyway, why not just make it that? It makes it much easier and simpler. Yeah.
Okay, thanks.
Hi,
Let's
can you
go.
hear me?
Yes, we can hear you.
Great. Hey, so just a question, I guess. The arrows 1 and 2 are about issuing the ID token, and the arrows 3 and 4 are issuing the ID JAG. Is there any reason it should be from the same IDP authorization server? Are you assuming that, or can that be optional?
That is pretty core to the model of this, the security model of this, and yeah, it's pretty core to this. If that's essentially the restriction that this draft does on top of the identity chaining draft that doesn't necessarily arrange the roles in this exact scenario. So if you're talking about different relationships, you might be better going and looking at the identity chaining draft and applying that to your model.
But why is that required? I mean, why can't an enterprise have, what you're trying to solve is the enterprise use case, right? And why can't an enterprise have an authorization server that is different from the identity provider?
It's because it's not an authorization server, it is the identity provider, and it's the thing that issues the ID token is the thing that is then consuming the ID token again, rather than using an ID token across domains, which is not good.
Okay.
So and same with refresh tokens, like you wouldn't want to use a refresh token across domains. So the thing that issues it needs to be the thing that is consuming it as well.
Okay, thanks, Atul. We have a few more people in the queue and we are running out of time. So Vanshad.
Yeah, Vanshaj. In this flow, if I'm the client in the wiki app and I make an OAuth request to the chat app, does the chat app reject it, or how does it redirect me to the IDP to use this model instead?
It does not redirect. So the premise is that it knows, again, somehow, hand wave, which was that question I had earlier, it knows that this chat app supports it, and it will do it instead of a redirect proactively. The goal is that there is no user flow visible in this.
Okay, cool. Thank you.
Go ahead.
Hi. Yeah, just I would like
State
to
your name, sorry.
Yeah.
State.
My name is Mohibul Mahmood.
Okay.
And I'm a relatively new IETF participant. So,
Welcome.
So yeah, thank you.
Okay.
So I would like to go one step back and would like to ask, like, what breaks today if we would like to use the normal token exchange? So like what, why we need this, like on top of this, why you need this grant? Yeah.
The quick answer is that, again, the token that's being used in the token exchanges is issued by the IDP, and you could have a situation where the token that's returned from token exchange is accepted by the other resource server. However, our feedback when we started working on this was that there is no scenario in which somebody else's authorization server will trust, or resource server will trust access tokens issued by an IDP. It's just not going to, they're not going to deploy it. Like if you go to a chat app and you say, please update your API to accept access tokens issued by big enterprise IDP, they're going to be like, you're crazy. That's not going to happen. So this essentially lets them use their existing OAuth infrastructure and existing access token infrastructure to issue their own access tokens in their domain in response from something that came from another domain.
Thank you.
Okay. We ran out of time, but do you want to introduce the next topic? Like you have a few more like open issues that you want to discuss, or do you want to just introduce
Just
it?
introduce them.
Yes.
Yeah. So I'm not going to go into these, but just to call them out because these are things I do want to address in the next version. Proof of possession binding. I have a proposal for how to essentially add Depop to this whole flow. It is using mostly existing building blocks, but there is a proposal on Friday that I will go into one of the new things that is needed for this to work. So I'll talk more about that on Friday. It's also useful outside of this. Chime in on this issue if you have any thoughts. And then the other one is way too complicated to get into in the last negative 30 seconds, but multi-tenant applications, resource apps. I tried to make this picture make sense. Essentially, when it's the same app, it's installed multiple times in an IDP. We need a way to point to which install of it you're trying to talk to across this whole flow. Again, there's a link here to a discussion about how we want to handle this. We basically need a name for what to refer to these things as. So those are the top priorities for this. And again, this is based on the feedback we've been getting from people who are in the middle of building this.
Awesome. Thank you, man. Okay. Next. Yeah, thank you. Brian. Yeah, you can't get rid of him.
I look more photographs, and I am taller than Aaron, just for the record. All right, updates to OAuth 2.0 JSON Web Token Client Authentication and Authorization-based authorization grants. I can't even say it out loud. There's once was too many. Let's move on. That is Montreal, though. Beautiful city. Am I doing this one? Okay. All this started back at OSW in 25, and I have a little asterisk there because it didn't really start at OSW. It started a little bit before that, but it was all publicly announced at OSW. And that asterisk, just to give a little bit of background and credence to, that's the wrong word. Sorry, I'm struggling today. To where this came from, there was some security, there's context, credit to those that discovered it too, and why it was discovered. There was some security work done doing an analysis of OpenID Federation, which builds on a lot of the OAuth constructs and OpenID Connect. And during the course of that formal analysis, they discovered a obscure but very real vulnerability in the combination, the use of metadata published online for an authorization server and the private key JOT client authentication method that could result in a malicious authorization server obtaining JWT authentication for a client that was not really for it, that it could turn around and reuse and replay legitimately and impersonate that client. And these are the security researchers that discovered it, and the OpenID sort of letter-headed paper that announced it originally, as well as the paper that they wrote. Anyway, we did finally talk about this more publicly after it was announced at OSW at IETF 122, and this is literally so meta it hurts. This is me up here presenting a screenshot of the recording of a session at IETF 122 that is Mike on stage handing me the remote to talk about it while my slide is up there, and the slide is a picture of me, of a picture I took of Mike taking a picture of the security researcher presenting the original findings. And I'm not even sure I did all that right, but it all is to point to that we've been thinking about this for a long time, and we can see it through different lenses through the way that we look at it. But both Mike and I have been working on, in conjunction with some help from various members of the working group, a formalized Philip Thank you, Philip. Have been working on updates to this particular document as well as a few others that touch it to close this gap. And the nature of how we've chosen to do that has varied a bit based on interpretation of the original findings, but I think that we're very close to something that's really in good shape now. And so,
Oh, it's not working.
there we go. Is it your machine? Okay. And then at 123, and so here we are again talking about 122 while we were at 123, and now I'm talking about 123 at 124 with a screenshot of 123. But the gist of it was we have decided to scale back the scope of changes in the document, make a very targeted set of fixes for the actual problem at hand, and break fewer things as we move forward with a fix for this particular problem. And that largely amounted to, again, targeted changes, updating JWT-based client authentication in a way that made sense, requiring that the issuer identifier from the AS, a construct that didn't exist at the time that private key JOT was originally developed, requiring that that be the sole audience, giving some constructs to explicitly type the JOT as a way for receivers of it to have a signal that the client is understanding and doing the right thing, but not requiring it. Make an update to the document that admits that SAML-based client authentication has never happened. It was probably an unnecessary construct to define. So rather than trying to fix a security issue that would exist in it, admit that nobody does it and just say, don't do this ever going forward, which won't be a problem because nobody does it. And then make more targeted updates around advice for the authorization grants, the JAGs that Aaron was just previously talking about, can be used in ways that are not problematic based on prior usage. And the real way to prevent misuse that might come about through these security findings is to make sure the client is doing the right thing with it. So we provide some advice to towards that end rather than adding strict new breaking requirements on the validation side. We discussed these changes with the researchers while we were at OSW, and it's taken us a little time to get to where we finally are. But sorry.
We have 4 minutes and you still have 5.
I know they're fixed.
So, okay.
I'll roll through them pretty fast.
Okay.
I got it.
Perfect.
I know. Thank you. So since Madrid 123, we published one draft version. And that was 03, basically doing some of the things I just talked about, as well as a few housekeeping things. We updated or requesting updates to the registry so that things previously pointed to by the prior document will be pointed to by this. So for the few individuals that actually find things originally through the registry, they'll be pointed to the security update in addition to the prior stuff, so they have that context if they missed the updates in the eventual published RFC. We do not restrict the odd claims type, so we now allow it to be either an array with a single value or a single string type, which is just semantically allowed by JOT and is security-wise the same thing. We'd had some prior text in the document that felt like it was a little bit overreaching in the face of simplicity, but it in fact would break potentially a number of real deployments that were producing these assertions the other way. We advise the client to ensure that the audience of an authorization grant makes sense with respect with where they're sending it to. So again, pushing the onus in this case on the client, which is really the only one that can prevent problems with misaudienced and misused assertions. So in that for authorization, so describing that, saying what needs to be done and removing some of the hard updates on the server that might cause breaking changes to actual deployments. We update the abstract in the introduction to hopefully a little bit better reflect the scope of this more targeted work. The updates were previously a little bit broader and they were scaled back. Some of the commensurate text in the introduction and abstract weren't changed at the same time. So this just kind of reconciles things, make it say what it says it's going to do. Removed an example that didn't really make sense in context. Again, some more updates to the registry for different things that were registered, but just making sure that eventually things will all point to the right places and you can find the information that you want. And fixed up the actual content in the one now pretty extensive example of JOT client authentication. Now hopefully makes sense end to end and has all the right pieces in play. We also updated the title to that long and horrible thing that I said before, which is really long and horrible, but is, I think, accurate. And we couldn't come up with something much better that was shorter. But we did also update the abbreviated title. So the word ass now appears significantly less in the document than it did previously under certain renderings. I know it's unusual for me to make this kind of change to remove something like this, but I thought I would try to do the right thing here. Justin? Oh, yes.
I do not support this change.
I didn't really either, but it felt like the right thing. Sometimes we try to do the right thing. And so I believe this is French for, is it time to consider working group last call? I really do think, like, we've been trying to push this forward. I know Hannes will maybe jump on me for adding changes and then asking for working group last call, but literally this is where we wanted to be a few months ago. It's taken us a little time to get there, but I think we're in great shape for it. And I'll just finish off my postscript here that while we're getting really meta, as I was taking screenshots of the various previous meetings, I noticed that Mike was wearing the same shirt in both Madrid and Bangkok. And I chuckled, and I was chuckling to myself a little bit about this when I thought and remembered that I had noticed the same thing about myself looking for content at a previous OSW, and I had the same shirt on in Norway and in Stuttgart. And so I wore that shirt today just to celebrate the moment.
Okay. So anybody against kind of starting our group last call? No? Okay. So, Hannes, I think you could do that, right?
Yeah, we definitely have to schedule a working group last call since it gets closer to a year and we wanted to get this done as soon as possible. So yeah. I think we really need to pull a trigger here.
Okay.
Thanks for doing the work.
Thank you, man. Okay. Next. Okay. Nice shirt. Okay. Go.
Okay. Hi, me again. Aaron Parecki. This time I'm here to talk about OAuth 2.1, our long-running effort to update OAuth 2.0. Now we are on draft 14. I'm going to give you just the slightest amount of background on this doc, and then get into some of the topics I wanted to discuss here. So just for reference, this is what OAuth 2.0 looks like today for all practical purposes. There's a handful of things have been added to it. There's a handful of things have been removed. Things have been progressing. We now have the security BCP as RFC 9700, and the browser apps BCP has been submitted for publication. Just held up on a couple of things on that. One thing, actually. So OAuth 2.1 is meant to basically take this picture and smush it all together into a doc that is a new baseline for what we consider modern practices of OAuth. What this really means is that we are taking a bunch of RFCs and pulling the bits from them, applying the changes where they say to change things, but if at all possible, trying to avoid defining new behavior in OAuth 2.1. It's meant to be what people are doing with OAuth 2 today if you are following all of the best practices of OAuth 2. So yeah, the two docs that have been sort of holding up some of the progress we could have made on OAuth 2.1 are these two. both of which are effectively done at this point. So we need to push the finish line with the rest of the doc. Since draft 12 was the last one presented at an IETF meeting. There have been 2 revisions. I don't remember why they were done in 2 chunks. Anyway, these are most of the edits since draft 12. Bunch of references to the security BCP updated. Awesome. Added references to where we talk about client secret posts and client secret basic that are actually defined in 7591. Some of these other ones are based on some of the feedback that we've been getting from people, you know, on GitHub and such. So there's mostly language clarifications. One of the biggest ones is actually this third to last bullet point about native apps. This was something that was part of one of the very first reviews on the doc, but this was essentially that most of the contents of the native apps BCP actually applies to mobile platforms and does not really apply to desktop, as in it's not really practical to enforce on desktop platforms just because of the tools available. So I went and sprinkled in text throughout that kind of, it doesn't prevent you from applying the advice on desktop platforms, but it tries to make it clear that most of these things are in a mobile context. So that was one of the big things hanging over my head for a while. We talked about this a couple of IETFs ago when we made that call to make that change. There was another change where someone wanted to make sure that it's clear that there is no requirement for an authorization to support either type of public or confidential clients. That is still just a choice you can make. So that's now hopefully more explicit. And a bunch of just editorial changes as usual to clean things up. So open issues. There are still quite a few open issues on GitHub. Most of them have some discussions in the GitHub threads with some of them have resolutions that need to just get spec changes done according to the discussion. Some of them still need some discussion, so please do review the issues. And some of them we have already discussed in past meetings. So I pulled out a couple to talk about today to hopefully get a resolution on a few more of these. This one is interesting. Issue 171, essentially a redirect URI or an authorization endpoint technically are allowed to contain query parameters in them, which means what happens if a client defines its redirect URI as a URI that includes the parameter code or state or any other, or ISS, or any other parameter that we would expect the authorization server to append to the redirect URL. Turns out that behavior is not well defined anywhere and can cause some problems. What should we do? One suggestion, which I think might be the most efficient solution to this problem, is to say there is a registry of OAuth query parameter names. Don't use any of those in your redirect URI or any endpoints that are OAuth endpoints. Thoughts, concerns? Philip.
That makes total sense. I don't think there's any particular issue in appending code twice. That's still a valid query string. It's still a valid URL. And if the client would be, let's say, unfortunate enough to actually register with a code in its redirect URI, then it must be ready for that being the case. But I haven't seen that done in practice. So just making a statement saying do not register these URIs with parameters from the registry makes sense.
Thanks.
Hi, Justin Richer. Yeah, I think it makes sense. I think it's debatable whether this is a normative must or should. Philip does make a point that if a client knowingly steps into this space, they should be prepared to handle it. I will add that that the behavior of multiple parameters of the same name is officially undefined behavior, as per the What Working Groups version of the URI query parameter spec. In that it could be interpreted in a number of different ways, all of which are perfectly reasonable and valid, and any of which could actually be handled by any part of your HTTP processing and parsing stack. And I ran into that firsthand on some implementations of HTTP SIG because we had to very precisely define how to deal with this nonsense. What we did there was basically throw our hands up and said, if you do this, you're on your own. So I think at the very least a warning, maybe a should not is reasonable here, with the warning of why it's a bad idea and pointing to the various specifications where this is defined. If you need specific anchors for where that language is defined, something that is RFC compatible, ping me. I had to dig them up I had to get what working group to define those in a way that RFC editor was happy. Ping me, I'll get you the URLs.
Okay, so based on that, I think I'm going to go ahead with, let's make it a should not use things from the registry and all the context about why, but must not, because if a client really wants to, they do have their own path to resolve the conflict they created for themselves.
Yeah, and then it's not a normative change from two, but it's also not something I've seen clients do in the wild.
Great, okay. Unless there's any other last concerns, I'm going to move on.
Yeah, next.
Great, okay. This one, 162. There is an error response defined in the spec that says it's called invalid client, and if the client presents client authentication that is not valid, the authorization server can respond with invalid client, including 401, and in that can list the supported client authentication methods or schemes. So this would be like, if this is different from like an invalid client secret, this is like the client presented some CBOR token and the server's like, I don't know what this is. It's not a client secret, so please try again with a client secret. However, if you are trying to indicate support for something like private key JOT, it is not clear how to indicate that, because there is nowhere that is defined in anything for the www authenticate response. In this thread, most of the comments have coalesced around, this isn't actually a useful thing to return anyway, because what clients actually dynamically choose their client authentication method based on responses from the authorization server. So can we just take out this sentence entirely about may return supported client authentication schemes, because it's not really used and nobody cares.
Philip.
Thank you. If the may is not present, then all the authorization servers that actually return 401 today would be not compliant anymore with 2.1, because the fallback for any auth error response is a 400, and that I believe is a must or a should, unless specified otherwise. So if we remove the may here in 2.1, the authorization servers that actually do use invalid client with a 401 would be breaking the 2.1 spec.
Is there a way to rephrase that to only remove the part about the supported client authentication schemes, but leave the rest of the 401?
You got me there, I don't know.
If there were, would that be acceptable?
Justin.
Yeah, to answer Aaron's question, I think that we can, because it's the interpretation of the error message by and large that we're trying to narrow here. And is there an additional, I did not look this up, but is there an additional parameter that says valid auth methods, or?
It's like part of the www authenticate challenge response header.
The additional methods are listed there, or are you saying that there are not?
They are listed. I should have put an example in the slide.
The schemes are listed, but the problem that is described here is that private key JOT has no associated scheme.
Right, because it's not an auth scheme.
Yeah, okay. It's not a www authenticate.
This is a mess. Can we ignore it?
Well, that's why I want to do by taking it out. That's what I'm saying. But to Philip's point, it seems like we need to make sure that there's a path for the server to return the 401 part of the error, but maybe we can just remove the rest of the auth method challenge parts of that.
Can we though? Because the www authenticate needs to have a scheme, I think, and it needs to have at least one parameter.
Yeah.
Yeah.
Okay. We're kind of stuck.
If only private jet has an issue, can we just not like do an addendum to a private jet?
To actually define an auth scheme for private key JOT?
Yeah.
Yes, but again, that gets to the larger point of like, I don't think anybody actually uses this mechanism anyway for negotiating client authentication. So what's the point?
But should they? I mean, like.
I don't think so. Most things are just hard coded and they know what client authentication they're going to use, or they don't have client authentication.
And the auth scheme is really meant to be a challenge response, and it's defined at the layer that a lot of the OAuth client auth is at a different layer entirely. So there's like this impedient mismatch between how you challenge it for what would be supported. Mutual TLS is another one that you could fail, and it would be inappropriate. Like, and a 401 doesn't match because in order you are required to have authorization header or www authenticate in a 401, and it's really nasty. I wonder if there's a way you could even, really the only one that's ever is basic, because it's client secret basic over that. So I wonder if you could just say that if it's supported or if it's or something without getting into supported client schemes or something. That's not.
It seems like generally the sense is we don't want to make current servers non-compliant, but we also don't want to really define this mechanism. So maybe we will just try to find a way to slice that. And yeah. Okay.
Maybe be just pragmatic and write it down like this into the spec.
Like, this is a problem.
Yeah.
Yeah, fair enough.
Otherwise, this will just stay here, and the only way to get context is to go to YouTube and watch this recording, and I don't want that.
Yeah. Fair enough. Okay. Yeah. Okay. That sounds good. We only have not enough time to actually give this a proper discussion here. I didn't think we would. This is an open discussion. There was a message posted to the list in September. There's a pretty long discussion on the list, but definitely not a conclusion. So this is still an open question. How can an authorization server indicate and actually support both 2.0 and 2.1 clients, letting the 2.1 clients opt into the new behavior and new requirements while not breaking the 2.0 clients that want to have the older behavior? Not conclusive. This is one proposal. Please, if you have opinions, please chime in on the list or on the GitHub thread. And I think that was oh yeah. Last slide. Anybody who wants to help with language for any of these issues, please help. The editing of this document is not limited to the editors and authors. Feel free to propose text on GitHub, send pull requests, or just write stuff in GitHub issues. Your feedback, your contributions are very welcome. Would like to get this over the finish line.
Okay, thanks, Aaron. Philip, do you have a quick comment there? You wanted?
I had a very quick comment about the discoverability, in that you can have a client which works with both 2.0 and 2.1, and you don't need any discoverability on this.
Okay, let's take it offline.
Yep.
Okay.
Great,
Okay.
thanks.
Thank you. Okay. Just okay. Okay. And I think you have control there. Okay.
Okay, so
So-
I'm Jonas.
Yeah, so since this is your first time here, you want to introduce yourself here so people know who you are.
Hi, I'm Jonas. I'm doing my PhD at the University of Tübingen, but now I'm here in my position as an IT security consultant at SÜS. We are doing penetration tests, and while I was doing my last penetration test where I tested some OAuth implementations, I figured out that we need to talk about browser swapping attacks. So, before we talk about browser swapping attacks, I should give you some basics about the OAuth authorization code flow. I expect most of you know it already, but I think it's better to repeat it. So this is a basic authorization code flow, as it is mostly implemented in clients running at the back end. So this means in step one, the user navigates in his user agent to the client backend. And since there's no active session right there, the client backend redirects the user agent to the authorization server, which is called the authorization request. Then the user is authenticated by the authorization server, maybe by a cookie session, which already authenticates the user, but maybe he also has to sign in. Afterwards, he's redirected to the redirect URI to the client backend, and this response contains the authorization code issued for the user. What the client backend does then is it resolves the authorization code for an access token, and after that, some other things happen, and the user is logged into the client. So, as many of you might know, this authorization code flow, as it is presented here, is vulnerable to a cross-site request forgery attack because the attacker could perform steps 1 through 5. And inject this authorization response into the session of the user as a CSRF attack. And then the attacker's authorization code will be resolved within the user's session for an access token, which means the user is then logged in as the attacker. So we have some protection mechanisms here, as it is stated in the original OAuth standard. The attack or whoever wants to sign in, the client includes a state parameter, which is randomly and not guessable by the attacker. And this one will be included in the authorization request. And the authorization server will reflect this the state parameter in the authorization response. And the client will compare this state parameter within the authorization response with the state which is coming from the session of the user. In this case, because it's a CSRF attack, it will be detected. And therefore, the authorization code will not be resolved for a new access token. Now, my question was, what happens with this authorization code here? Well, nothing. This means this authorization code remains valid and it has been transferred in a query parameter. So if the attacker gets to this authorization code in any ways, he can use it and resolve it. Now, obviously, in this case, it does not make sense. And this is why browser swapping attacks come in, because in a browser swapping attack, the CSRF attack does not happen here. Instead, it happens up there. So this means the attacker only performs step 1 and 2 and hands over this authorization request to the user. So in the context of the user clicks the link, for example, because the attacker asks him, hey, Mr. Administrator, could you please check my permissions here, something like that. Then the administrator clicks that link. Maybe he's already authenticated due to an active session with the authorization server, and then he will be redirected back to the client, and the client will not resolve that authorization code. In an application which I have tested last week, then the client backend simply responded with a 400 bad request. Well, what will the administrator do in such case? Obviously, since the original link here was sent by the attacker, he will ask the attacker, hey, your URL does not work for me. Could you help me, please? Then the attacker says, oh, that's no problem. To me, last time the link worked, but could you please send me your link where you are redirected to? And if the administrator does not know that this URL contains a secret, then he will simply send this link to the attacker, and the attacker can then repeat this request and will then be authenticated within his own session, but as the user. Since because now the state parameters matches, and therefore the authorization code will be successfully resolved for an access token. So what can we do here? Let's first talk about how this can happen, because this can happen in many ways. For example, this URL sharing attack, which I just demonstrated. The reason why it works is simply because the authorization code remains in the URL bar of the user, and many users do not look at what query parameters are included in this URLs. One example for that is I assume most of you have Amazon Prime, and many of your family people send you some links and they do not remove any query parameters there, so they will not check it if there is some of this codes included there. So another reason why this authorization code could be leaked is, for example, in the referrer header. For example, if some static file or resource, just like the favicon or something like that, is included from an external URL, the browser by default sends this referrer header if there's no referrer policy defined here. Then yeah, there's obviously also some Google Analytics stuff or stuff like that. The simple solution here would be do not include Google Analytics or something like that into your redirect URI where you receive the authorization code. But another thing which I figured out is that logging could be a problem, because there are many different services involved in modern infrastructures. Since time is close, I will not go over all of them, but if you have any questions there, feel free to ask afterwards. So when I discovered this, I talked to Aaron, and his first idea was, well, that's not an issue, right? Because we have Pixie. But I can tell you this thing here, no, Pixie will not help here, because let's have a look how this flow works with Pixie. The problem here is that the code challenge is defined by the attacker. And in this case, it also comes from the session of the attacker. And therefore, the corresponding code verifier also comes within the attacker session. So in theory, yes, Pixie helps here, but it helps the attacker to protect the authorization code from the user stealing its own authorization code or access token. So no, Pixie does not help here. What could help here? Well, the best thing would be if the authorization code is not leaked in any ways. Against this logging issue, the response mode fragment will help. Because in that case, the query it's not a query parameter where the authorization code is included. Instead, it's a fragment parameter. But fragment parameters are not sent to the backend by the browser. So this restricts this attack to just the client and nowhere in the backend this authorization code would be included. Probably if you have content delivery networks and something like that and a misconfigured referral policy, then it might be leaked to a CDN, but I think that's in this time neglectable. However, the issue here is you can only use fragment parameters for front-end applications, for example, mobile apps or single-page applications, because they need to be sent to the backend. And for the backend, we also have a solution which is response mode form post, because then the authorization code will be sent to the backend as a post parameter, and this is also protected against this URL sharing stuff. Justin, you raised your hand. Okay, it's fine. But well, the problem here is this can be downgraded. Since the attacker controls the URL of the authorization request, which will be opened in the user session, he could also append the response mode equals query, and then it's downgraded and the authorization code will be sent as a query parameter again. And if form post or something like that was implemented in the client, this will definitely cause an issue because it does expect the authorization code as a post parameter. Philip, you also raised your hand?
Yeah, thank you. I would like to question whether it can be downgraded, because a client will usually be written with the response mode in mind, and if it expects a query parameter, then it works with a query parameter and will not be exposed to accept form post. Likewise, if it is written for form post, it's not going to have a get handler for the get with the query string.
Yeah, but the problem here would be if it's only expecting a post parameter, so a post request, then you will probably get a method not implemented error or something like that if it's coming as a query parameter. And most probably, this case will not be handled by the client application, and therefore you still have the authorization code as a query parameter in the URL bar.
Mm-hmm. And then you're expecting the user to be smart enough to take the URL and copy it elsewhere.
Yeah. Okay. But as I showed you before, this is something which is pretty realistic, because users most probably are not familiar with what query parameters can do, especially because they even skilled people do not expect any secrets in query parameters, because they could be logged somewhere. So in addition, I recommend, because this was also my first impression how we could circumvent this issue, we should have an option how we can, or how the client can invalidate authorization codes. For example, if there was CSRF attack detected and the authorization code should be invalidated so that no one else can use it afterwards. The reason why I say that this is not the only solution which we should provide is because in theory, I would not expect this in practice, but in theory, it's possible that, for example, if the authorization code is leaked via logging or something like that, the attacker might access these logs before the client was able to resolve the authorization code for an access token. So the problem here is, I don't think we have any way how the client can invalidate an authorization code at the authorization server, because it's as stated in the standard, the only way is to send a token request. But I think in OAuth 2.1, this is only possible if you get an access token, but this is not what we want here. I also figured out at some of our customers that it really depends on the implementation of the authorization server, how we can send the authorization code to the authorization server without getting an access token and with invalidating this code. One example is providing wrong or no redirect URI in the token request. The problem here is in the next authorization server, which I tested, this did not work because the authorization code was not revoked. I think it is because it was not associated with any legitimate request because the redirect URI was missing. So this is something which I recommend that we should change it. So to conclude all what I said before and what are my recommendations for OAuth 2.1. First, this is pretty controversial, I know. Do we still need response mode query? Because I think, really? For what cases? Just for legacy reasons, or because it cannot be done in any other ways? Because I think, for example, for mobile applications, front-end JavaScript web applications, response mode fragment works well. And for all these backend applications, response mode post form would also serve well. So in my opinion, response mode query is just a legacy parameter, which has the problem that probably the authorization code could be leaked. But I'm fully agree with all of you who say, yeah, but we still need this for legacy, so we should not deprecate it in OAuth 2.1. I fully agree. But what we should do then is we should say in the OAuth 2.1 standard that it's mandatory for authorization servers to provide client configurators or implementers the opportunity to enforce a specific response mode. Because only this is able to prevent such downgrading attacks where the attacker simply adds a response mode query or something like that to the authorization URL. Last but not least, we should also include some specification in the authorization server how we can invalidate an authorization code which the client has detected that it has been used, but it should not be resolved for an access token. That's all from me. Aaron?
Yeah, hi, Aaron Parecki. This is a lot. I don't know how anybody else was following this in the very short time we had here. This would be like an hour to go through the slides last night to fully understand. It is very important. I agree this is a real attack scenario to consider. I don't think it's realistic, frankly, to deprecate response mode query for just a bunch of reasons, only one of which is that the other response modes aren't defined in IETF at all. They're OpenID Connect specs, but that's just the tip of the iceberg there. That said, I do like your other two suggestions here. And those seem like security considerations. Well, the second one is just like advice for implementers. That's great. The third one is an interesting idea. It's new functionality. Could be worth a spec to extension to formalize that. I don't think we can just do that in 2.1 because it is a very new functionality. But largely, I think that the effort of fixing this particular attack is has relatively low value compared to a lot of the other places the OAuth flows are attacked, like bearer tokens, stolen tokens. Like you can secure this all day long, but it doesn't matter if the token is able to be stolen at the end of the flow. As well as OAuth phishing, where the protocol works perfectly, but the user was tricked into issuing a token to a incorrect app, and there's nothing wrong with the protocol.
Clicking the authorization URL.
Yeah. So those feel like higher priority places to work on. So I want to minimize the churn that is created by solving this. So keeping the changes to things that are implementation advice and things like you mentioned of removing the code from the redirect URI when you're processing and not using ad trackers, et cetera, et cetera. Those are all like solid advice, and I would like to keep the recommendations at that level.
Okay, thanks, Aaron. Philip, quickly, we're running out of time here.
Yes. Aaron pretty much summarized what I was about to say about the priorities. For point number 2 in the FAPI2 message signing spec, which requires a particular response mode to be used, we did introduce a client metadata for being able to do this, so that the client is required to use a particular response mode, and so the authorization server enforces that it sticks to its pre-registered response mode and cannot be downgraded, quote unquote. Speaking of FAPI 2.0 security profile has had an official attacker model defined, and it just uses the standard query response mode and uses PXE as required. So my question would be whether the attacker model doesn't cover this scenario or whether there's anything amiss.
Yep. I also looked at the FAPI2 security profile, and there I saw this browser swapping attack. And my impression was the standard solution for this is, yeah, you should keep the query parameter code confidential. But obviously, in this case, it does not solve it. So yeah, you're totally right. FAPI 2.0 does not cover this in any way.
Okay, Justin.
Yeah, just really quick. The suggestions here, I agree 100% with Aaron's suggestions about how to take this in. I also want to point out that these suggestions only prevent leakage. They do not actually provide mitigation. And I think that if we're going to lean hard into like how to close this gap, if we really believe this is closed, then we should be focusing on mitigations, not leakage prevention, because we close this in one place, it'll just end up leaking in other places. There is also already existing good security advice in the community in general. I don't think it's made it into a spec yet, because I don't think we have it in 2.1 yet. But about sanitizing your the parameters on various pages before they're actually served to the user. I know several implementations of OAuth and OIDC servers that do that in practice, and because it's a good idea. Extending that advice to clients as well is also just good advice, but nothing's going to say that you put something in a fragment and the client's not going to turn and post that to a backend server to go do things. I've also seen clients do that, for the record. Implicit flow with a backend. It's anyway. Point being, yes, do what Aaron said.
Okay. So do we need an interim for this to kind of hash this a little bit more, or is it do we have a way forward?
I think there's enough concrete proposals in this right now to just go ahead with some text. Okay. And we don't need the sync time to do that. Maybe we can work on that first and then see if we need more time.
Sounds good. Okay, perfect. Thanks, Jonas. Thanks. Is Sohas here? Yeah. Okay. Yes. You want to introduce yourself first? Okay. You're new here. So.
Hi, let me do this. Hi, I'm Suhas. I've been with IETF for more than 10 to 12 years, but I've been focusing on real-time media applications and signaling on that side and a bit of crypto, but right now my focus has been on the media quick working group. And some of the things I'm presenting here has been because of the need that was there in the media quick working group, and we wanted to see how can we support something like that, what we need there. And this is the first time I've always been the OAuth user. This is the first time I'm bringing in some work here, so I want to get your feedback on that. Okay. Cool. We presented a proposal called Depop Proof. Depop Proof is a parallel proposal to what we have in RFC 9449. It's not very different. The main difference being that the current Depop draft is specific to HTTP, and we wanted it to open up to support different transports. The reason for it, I'll go on to explain next. Next slide, please.
You have the clicker.
I kept inside.
Yeah, so you can put that back. Yeah, yeah, there you go.
Okay. Can you hear me? Okay, that's good. Okay, the motivation is like the meteor working, meteor quick
You
is
can
an
adjust it. You can adjust it.
Oh yeah. Thank you.
Oh, you probably. You wanna use this here? Is it back? Is it? No? Yeah. Or use that.
I tagged Meet Echo. Hopefully they can run and be microbat.
Thanks, just.
Okay, finally we have the working mic. Thank you very much. So the Meteor Quick is an application transport that uses PubSub API to distribute media. And the main thing here is that there are endpoints called the publishers and subscribers. They use publish or subscribe API to send data corresponding to resources. The resources here are identified by what we call as a combination of track namespace and track name. You can think that as very similar to an URI, but semantics changes a bit. And the way the data between the publishers and subscribers get distributed is using what we call as the mock relays. These are the intermediaries, and they authorize the resources based on some of the mechanisms that we did.
Yeah, you can. You have to look there. You can.
That's good. Thank you. So the thing is that these media relays can be thought of as nodes in the CDN network, and the mock has adopted what we call as the common access token format that to authorize these resources and the API. But CAT, what we call for the common access token, support DPOP, which is again HTTP based. So we would like to extend the DPOP to support mock actions, and that's the reason why we bought this work here. So we tried to approach this problem in two different ways. The first thing what we did was we thought if we can map every mock action or the mock verb to a HTTP action, maybe we don't need to do any changes. Things started pretty easy. For example, mock has subscribe, or mock has fetch, which is very similar to what get HTTP get is in the but and it also has publish, which might map to the post or put. But the more we go deeper into more mock messages or the mock verbs, the mapping to HTTP was not easy. For example, we have a client setup and server setup, which are used to set up the mock sessions. There's no one-to-one mapping between that and an HTTP verb. The same way when we talk about the publish namespace and subscribe namespace, which are authorization to the partial URI, there's no equivalent to HTTP that we can match the semantics one by one. So we decided to abandon this approach and go to the approach 2, which is what we are presenting here today. In this approach, what we call as DPOP proof, we have what we define as an authorization context object, which is a transport application agnostic. All it defines is it defines a type, which identifies a transport. In this draft, we define the type of the mock transport. Along with that, we define some of the verbs or the actions and the URIs or other things that the transport requires to be authorized for sender constraint behavior. So if you look at an example here, if we use the authorization context type to be mock, and then each action can be one-on-one mapped to the mock action or the verb here. And this is how we would want to extend to generic transport. This can be extended to new transport that comes in the future, or we want to rewrite HTTP with the same transport, that's also possible. And here I'll show an example where we are using the authorization context for the type mock. And one of the actions that is being authorizing is subscribe. And the resources that identifies that is a full track name. The TNS corresponds to the namespace and the TN corresponds to the track name. So this kind of gives the receiver of the depop and depop payload to understand that what exact resources has been sender constrained and needs to be authorized based on that one. So just comparing what draft 9449 says about in section 7 about the protected resource access and what we have done here, it's as it said, it's basically the originally the scope was on HTTP methods, URIs, but we moved to more generic authorization context object, and it basically keeps transport to be flexible, and at the same time we get to achieve the same cryptographic properties that we need for different transports in the future too.
It's not working?
Yeah, this is not working.
Okay, I'll take it.
One at a time.
Oh, there you go.
Batteries on there. Okay. Okay. The summary here is that like as mock is a new transport that needs the similar security properties that Depop provides, and based on because we are using the CAT as a token format to authorize mock resources, and Depop today is very tied to HTTP. We want this option to create a Depop version 2 and add something what we defined here into the other draft. But this is what currently the proposal is that they are different things. So if application wants to support something like the authorization context that we have defined here, they need to use Depop proof or whatever we call it as. That way it will give two different code path implementation, but we are open to extending how do you want to get that into the Depop framework. The ask here is that mock working group needs some guidance from the experts here on how do we proceed. Are we going the right direction? And based on the feedback we get here, we take back to the mock working group and make it work there.
Okay, thanks, Sohas. Any thoughts, comments? Deep thoughts from Brian here. Justin.
Clarification, is the request for adoption as a document here in OAuth or in the mock community, and you're just asking for sort of advice and eyeballs?
So right now it's asking for adoption in working group document here. Because the Depop experts are more here, and we'll get more expert time to resolve the issues here.
Okay, thank you. With that in mind, Depop already doesn't cover much of HTTP on purpose by design. It doesn't cover the whole URL, doesn't cover headers, doesn't cover body without further extensions. So it already seems like this might not be a particularly clean mapping to this larger authorization context or request. I forget what you called it. Unless you're also looking to extend it for the HTTP space as well. Is that a goal for this work, or is that an explicit non-goal for this work? Or you don't know?
No, I don't know. Basically,
okay.
What this draft currently defines is that how it can be done in full for mock. Mm-hmm. And if you think that adding HTTP would help the current implementations to have a generic way to define not just the mock one but also for HTTP, happy to add the details if needed. Yeah.
Okay.
Okay, anybody else has any comments? Brian?
Offhand, it feels like it might be more appropriate in mock. Mm-hmm. That's sort of an initial impression. And I wonder, like the binding HTTP for Depop was very much intentional. And it feels like it might make more sense in mock. And I wonder if you might want to consider not trying to define an application or a transport agnostic way of kind of doing all that and then putting in a mock specific variant, but just doing whatever you need specifically for mock and doing it that way. That's kind of the approach that Depop went with originally, was like, here's how you do it for HTTP, mm-hmm. Done. Might have been better other ways, but it feels like trying to make it generic at another layer for a specific need is going to be more work than you want to take on. And even in doing that, I wonder if you might want to consider just using, like, if you can get away with just using like the audience rather than a full context binding, which in some ways I wish Depop had considered, but that's sort of a longer thinking.
Right, like on two things. On the audience one, we tried, but that was more of a hack more than solving the use case that we wanted. And and can we make it just be mock specific? Yes, we can build something, but it finally came to the point that the same CDN servers that are implementing HTTP Depop, they would want to support mock resources as well, and it was. The feedback was like, if there's one way, it would be easier, and that's the way it came. But again, we're open to options here. Yeah, thanks.
Okay, Yaroslav. Thanks.
So I think generalizing Depop is a generally good direction because there are other potential challenges that Depop could help solve us. I see there is a bit of overlap between this work and Depop for refresh tokens that I plan to present on Friday. Maybe it's worth bringing it to dispatch next time and see if there is any guidance on building more generic Depop for other use cases.
Thank you.
Okay. Colin, you had a quick comment there?
Sorry, Colin Jennings. So, I mean, this is just, and maybe this is like for ADs later or whatever, but my take was the only working group that was chartered to make Depop changes was this working group. Now, obviously, dispatch could charter something new or whatever, but I mean, I'm fine to do this in mock too. We could do that there, but it's certainly not chartered for that. I don't know if ADs have any advice for us. Dispatch remains good advice, right?
Okay.
We have done several efforts already together with other working groups. Like currently, there's work going on email and OAuth, and so they are also doing some stuff. There was previously ACE work, which also did the Depop version for MQTT and co-op. So in that sense, there is some history, but of course, in sort of both groups have to work together in any case, regardless of where exactly the work happens, because the expertise is in both groups.
Yeah.
Okay. Makes sense.
So we'll figure it out. We'll discuss it with the AD and the working group chairs, as we did with the other groups as well.
Okay, quick, Aaron.
Just a quick comment. This does seem like a recurring theme of like other working groups want to apply OAuth, various parts of OAuth to their space, and it is not clear where that work should happen. And it's not necessarily good to just have it happen outside of the OAuth working group, even if it's not explicitly in the scope of the OAuth working group. So it seems like a problem that we need to fix.
There's something to think about here. Obviously, it's way too early to adopt a document at this point. So thank you for this, and we need to think a bit more about this.
Thank you for the time.
Yeah. We have one more presentation, and I need to take this. Is one of the authors here like to present this online?
Yes. Hello.
Okay. Go ahead.
Okay. Let me be very quick since the time is over. Hello, everyone. This is Ruochen, and we are presenting our work on OAuth delegated authorization. Please, can I move to the next slide?
Yeah. You can.
Okay. Yeah. Okay. So as we can see from this slide, what we have on the left is the traditional OAuth 2.0 protocol flow, and as we can see from the slide, the client needs to get an access token from the authorization server and use it to access the resource server. But there's a problem here that downscoping of the access token is not possible with traditional OAuth 2.0 flow, unless we use a mechanism based on token exchange, and token generation always relies on the authorization server, and the client is not able to generate a access token or make any changes to the access token on its own. That's why we developed this delegated authorization framework where the client can get a delegation token from the AS instead of a traditional access token. And after the client receives the delegation token, it will be able to issue a subordinate delegated access token on its own locally. And the client will be able to use this delegated access token to delegate a part of the permissions authorized to the client itself to a third party, which we call the delegated party here. And the client will then use the delegated access token to access the target resource server via the third party delegated party. So the key points here are we will use a digital signature linked token chain that's similar to traditional web PKI certificate chains. And only the delegated access tokens are accepted by the resource server or authorization servers, and delegation tokens alone are not accepted. And the resource owner will only need to request for one token from the authorization server, and then the client will be able to perform downscoping on its own. And generation of these delegated authorization tokens are done locally on the client. Okay, so on this page, we can see two example tokens. On the left, we have the delegation token, and on the right, we have a delegated authorization token. That's a subordinate token of the one on the left. So we can see that the part highlighted in blue color are the claims of the two tokens, and the claim set of the DAT are downscoped from the ones from the DT. And we can see both permissions and token validity period are downscoped in the DAT. And additionally, we have a delegation key included in the delegation token, which is a public key that we use for the digital signature in the subordinate delegated access token. And we also need to include the parent delegation token as an attribute in the delegated access token on the right, because for the resource server to validate the delegated access token, they will need to use the authorization server's public key to validate the delegation token first. And this token structure will support authorization code grant as well as other traditional OAuth grants, including refresh token grants, etc. And we can also support rich authorization requests in addition to traditional OAuth scopes. And we also in order to include this DAT in resource request, we need to design a new HTTP header, which we call a delegated authorization header, in addition to the normal authorization header, because for the client to send a request to the third party, which we call the delegated party, we might need to include two separate tokens. The first one is for the client to access the DP itself, and the second one is for delegating authorization to the DP to access a target resource server. And we have also designed a DP metadata structure for discovery. We more about it in the draft. And this structure supports local verification of DAT on the RS and token introspection via the AS.
Okay.
And we can.
You have a comment?
Yeah, sorry.
Okay. So we ran out of time, but Aaron has a comment here, and we will end it here. Look at this.
So I did try to look at these slides yesterday to see what this is about. I will admit I don't fully understand it, but it does seem like there's actually quite a lot of similarities in the use cases between this and the identity chaining or the identity assertion grant, where you're moving across domain and also doing binding of these with Depop, which I'm going to talk about on Friday again. My request would be to take a look at that draft and see if that can work for you. If it doesn't, let us know what's missing, because we might be able to cover these use cases with that existing work.
Okay, thank you. Lee, did you get that? Is that reasonable way?
Yes. Okay. I think later on I will write something about the similarities and differences with the other existing works. Actually, I have another slide on how it differs from token exchange based solutions.
We're 5 minutes past the time, so
okay.
We
It's
need to
okay.
finish here. So
We
sorry
can.
about this. Peter, you have a
Yep.
comment quickly, please?
It's just a quick comment. So I think this draft has a slight advantage, is that if we do this delegation token, we might be able to, one consider that the your resource server might be in your local domain, and when you can just switch, when you can exchange your delegation token to a delegation access token, when you have the full signature and the key inside of your token, you can just switch it. You don't have to go a round trip between your original resource server and to your, let me see, how should we phrase this? So the point is, I think, is that we can verify the signature of the delegation token at the just at the resource server, so you don't have to do a round trips. I think we have to look at that side.
Okay. Okay. Thank you. Thank you, Lee. Take a look at the other drafts and see if there is similarities there, right? So, okay. Thank you all, and see you Friday.